can't get the PDF? Alright. What's it saying? Is anybody else having that trouble? Oops. Okay, I'll come back and help you in a second. For everybody else, okay, once we have it downloaded and saved somewhere, open Squid. Again, if you're unfamiliar with it, it may already be on your main toolbar down here. It looks like this icon. I'm pointing to, could everybody see that? But if it's not, go into your apps, and it should be there. So in your apps, it looks like this icon right here. So Squid under it. Did you get that PDF, Bohan? Or are you still waiting? If you're having an issue, I could give you a hard copy. I printed some in case anybody had an issue. So I'm going to keep going and keep trying, but if you have an issue, I'll give you a paper copy for now, okay? Alright, once Squid is open, I already put mine in, but I'll just run through the process. I just want to make sure this is still working, because importing PDFs is part of a paid version, and every once in a while, I had to do it to mine today, an update which wouldn't let me import one. So you guys should have automatic updates, but I just want to make sure everybody can do this right now before we go on. So hit the plus sign in the bottom and select import PDF if you haven't already. And then you should be able to look in your drive wherever you saved it to open that. I already did, so I'm just going to close this out and open mine up. As you guys know, you should be able to zoom in and you could write in small spaces, right? And then go back out. Now to turn this in, again, I know a lot of you know this, but I want everybody to be on the same page. Once you're completed with something on here, go to export. Typically entire node, unless for some reason you were only supposed to do one page of it, okay? But for homework or to complete what we start in class, you're going to do both pages tonight. So make sure you have entire note and PDF, and you'll share it. And then you'll have an option to, I would first put it in my Google Drive, all right? You could go straight to Classroom, but I wouldn't, just in case there's an issue, okay? Go put it in, save it in your Google Drive, and then from Classroom, like you normally upload and turn in things, search for it there, put it there. Does that make sense to everybody? We all good with that process? All right. So another thing that can be helpful that I would guess most of you know, but how many of you know how to do a split screen on your Chromebook? Okay. Not everybody raised their hand, so real quick, let's show that. It's super simple. Because since you're typically not going to have a paper copy, so you don't have to keep flipping back and forth, obviously, from the site to this. All right, so when Squid's open and you have the document you want to write on, if you go to the little boxes up here that just makes it minimized, it'll do something like that. You just drag it to the right or left as far as it can. Oh, that did work earlier. Let's try to, then if we want to have the website up that we should have up here, I'll click on that. I'm going to minimize that, not minimize, but make it smaller. And if I drag this to the other side, there we go. Now I did it. If you drag it the whole way over right or left, it'll split screen them. That way, while you can look at the questions, obviously, while you're reading some of the text if necessary. It's helpful. I mean, if you don't want to do it that way, that's fine, but something, since we're going to try to do primarily stick with online stuff and turning stuff in digitally, that could be helpful. All right, so anyways, any questions about any of that? Bohan, were you successful doing that, or are you still, it downloaded? Did you get it on Squid? Here, let me for now give you, because I want to get started here. I did print out some. I just gotta find where I put them. Just in case there's an issue, we can't fix it later today. I'll give you a paper copy for now. Okay? But we'll get it taken care of eventually. We gotta get down here. All right. So, anyways, I'm gonna flip over to my other one. Yesterday we just barely started talking about scalars and vectors. We basically defined them. But can anybody remember anything we said? What's a scalar? How is a scalar quantity different as opposed to a vector quantity? Karis? Very good. We'll stop there for a second. Scalars only give us magnitude, we said. But what did we say magnitude was a fancy word for? Krish? Well, I want a more general answer here. The magnitude of something is just the something's what? Not necessarily. Or general. Size. All right? Magnitude means size. So an example I think I quickly said yesterday was when you look at a speedometer in a vehicle. If it says 65 miles per hour is just the units. The number 65 we refer to as the magnitude. It's a size, right? It's a size, the numerical size on some kind of scale based on the units that tells you how big or how small something is, right? So scalar quantities only give us size, but vectors give us what else? Direction, all right? And if we give how fast you're going, like 65 miles per hour, but at the same time, note that you're going 65 miles per hour north, it becomes better than a speed. It's giving you more information. Now we call that velocity. All right, speed and velocity technically come in a later lesson tomorrow, okay? But that's a good example for now we can all relate to, all right? So hopefully that sounds pretty simple, right? Vectors give direction, scalars don't. And by definition, it is that simple. But remember, we're just not spitting out definitions in here. We're applying stuff to situations, especially mathematically. So we got to remember, if something's a scalar and doesn't care about direction, when we calculate it, we don't care about direction. When something's a vector that does care about direction, when we calculate it, it makes it different as compared to how we calculate a scalar. And you'll see specifically when we get to two specific scalars and vectors today, and that's distance and displacement. Now there's some other scalars and vectors all year, every physical quantity all year we give. When we get to forces, we'll tell you and remind you force is a vector. That just automatically should pop into your head because we're learning this day one. Oh, that means force cares about direction. It has direction. Later in the year we get into energy, and I'll say energy is a scalar. So every time we meet a new physical quantity in one of our chapters or units, we'll always start by saying if it's a scalar or a vector, because it's an important concept. Either it cares about direction or it doesn't. So there's five physical quantities in this total lesson that we'll be dealing a lot with. They are distance, displacement, speed, velocity, and acceleration. All right. Some of the ones we won't stress today, you may have to go to the reading to answer in the worksheet. It will be very clear. Okay, most of the stuff I will say, but some of it you're still going to have to go to the lesson. We're in lessons A, B, and C, and read along, and it pretty much goes in order for the most part with the questions and everything. All right, so anyways, two specific physical quantities that we're going to focus on today are distance and displacement. Simple ideas. Hopefully after today, this is pretty easy. But simple ideas that if you don't get this down from day one is going to make some problems later that shouldn't be very difficult. All right? So I'm going to use a little simulation to discuss distance and displacement. But the very first thing is distance is a scalar. So it does not care about direction. Displacement is a vector. It does. There, in a moment with simple mathematical calculations, you'll notice how they could be almost the same thing, but they could be completely different as well. So We're just going to start simple. This is 1D kinematics. 1D means one dimension. We're going to study motion right now, starting with just somebody moving back and forth on a straight line. They're not allowed to do anything else. So this guy is just called the moving man simulation I'm going to use to this and refer to. Excuse me. And he's basically on a meter stick here, like a number line, okay? So obviously on a number line, usually the center is 0, the right's positive numbers, the left's negative numbers. To identify direction in one-dimensional motion, usually we just signify one way is positive and one way is negative, okay? It just makes the most sense. It's the simplest thing to do. But sometimes, you know, a situation will define right is east, left is west, all right? I would say, unless told otherwise, use plus and minus for direction, all right? But you are going to be told otherwise. If you're given a diagram in a situation on one of these worksheets, and like it clearly looks like right is defined as east and left is defined as west, the direction we put on our answer, we're going to go with that. Depending on the situation in some cases. But if they don't tell you what direction to use when calculating some of this simple stuff, just go right's positive, left's negative, okay? Simple enough, like on a number line. All right, so we have this guy, and he's going to start. I can move him anywhere I want. We're going to make it really simple to begin with. I'm just going to move him to the right. He's at the 0 meter mark. We also call this mark the origin, okay? Wherever something starts, that's the origin, just like the origin of an XY coordinate system, right? So I'm going to just simply move him one way and stop him. I'm going to move him right here. And we could just ballpark where he is on this. It says down here his exact position, but we could just be close enough by looking just on the measuring stick itself. So I obviously moved him how many meters to the right? 5 meters, right? So now it's all in how we ask it, though, that you give a simple answer correctly. If I asked you what distance this man traveled, what would you say? 5 meters. Distance doesn't care about what? Direction, right? It's a scalar. So that's good enough. He moved 5 meters. We don't have to say to the right. We don't have to say positive 5, whatever. We don't have to give any significant direction on that. If we ask for his displacement, now though, remember displacement's a vector. So same motion. The guy ends up right there where he is. He started from the origin, 0. What is his displacement? Anybody else that hasn't answered yet? Yes. 5 meters to the right, or positive 5 meters. Something that gives me a direction on it, right? Okay, but the key, one thing to focus on now, that this will change when I change up the scenario a little bit. So distance and displacement in this particular example have the same magnitude, right? Everybody agree? Both of them have a magnitude of 5. Distance only gives that magnitude. Displacement had that same magnitude, but attached to the direction, right? Okay, so let's go back to starting here. And we'll show a little bit different. This time, we're going to move 6 meters right, turn around, and come back to the 4 meter mark. Not 4 meters, but back to the 4 meter mark. So again, what I did, follow along here, because this should be simple, but it's a really important idea. I go to 6, turn around, come back to 4 right here. All right, so now, raise your hands. Who could tell me what distance this guy traveled? Jay. 8 meters, good. All right. Distance did not care that this guy did what? Yes. Turned around, right? Remember, not only by definition, but in thought, distance doesn't care, since it's a scalar, about any directional changes. It's a total. All right. So basically, we could have an example where we do laps around this room, constantly changing direction. But your distance is just imagining if you just straighten it all out, if you could. If you walk 3 laps around this room in circles, if you could straighten those out, that would be your total distance. It doesn't care about any directional changes. But now, let's ask the other question. What displacement does this guy have during that same trip from starting at 0, going to 6, and ending at 4? Good. Good, very good. 4 meters to the right. Now, let me give you another little tip if that doesn't make total sense. Another way to think about displacement, this is for displacement only, is from where we started to where we did what? Ended, right? So that's another simple way to keep that separate. Displacement is always from where we're started to where we're ended, which does account for a directional change, right? If it happened. If it didn't happen, it doesn't matter, like the last example. But if a directional change happened, it considers that, and only then considers the fact that from where we started to where we ended. So 4 meters, and you said to the right or positive or some significant direction that makes sense to the situation, right? To the right of where we ended up, or where we started. So there's a good example, though, where, as opposed to the last one, the magnitudes weren't the same anymore, were they? All right, so in the right case, distance and displacement can almost be the same thing, as in the fact that they have the same magnitude. But if there's ever a directional change, even one slight one like that, then your distance and displacement will be different numbers, different magnitudes. And displacement still has to have a direction tacked on when we say it. Does that make sense to everybody? All right, just based on that idea, a couple more on this axis, then I'll pull up some diagrams that are actually in the lesson. All right, so the origin doesn't always have to be the starting point. All right, this guy could start back here at the -4 position. So let's just do that just for an example of not starting at the origin. So let's say I go from -4 to 10, but turn back around to 8. All right, what total distance? What's the total distance we have on this one? Yes. Okay, so we got 4 to 10. You said 16? Okay, so the total distance in meters. Watch this and be careful, all right? 4 to 10's 14, and then you accounted for these two, right? Exactly. Does everybody see that? All right, because remember, distance could care less about anything with direction. It's just a total up. 1, 2, 3, 4. We're back to 0. 10 more. Turn around 2 more. Right? Total it all up. What's the displacement? I started at -4 and ended at +8. Excuse me. Yes. Okay, good. 12 meters to the right. The difference between there and there with the direction tacked on. Does that make sense to everybody? All right. That's the simple one-dimensional idea of distance and displacement. All right. Now, this chapter focuses mainly in 1D, but we still will bring in a couple simple two-dimensional ideas. Okay. So I'm going to use, I can't do 2D on this simulation, so I'm going to go to the distance and displacement page in the lesson just to look at this simple little diagram right here. All right. Just a rectangular path, as if we're walking around the corners of this room, okay? Just throwing in some numbers. I'm going to say, where my arrow is, I'm going to say, okay, let's say we started here. All right, we had somebody walk a rectangular path. There's the numbers. 2 meters that way, 4 meters, 2 meters, 4 meters. Okay, if I go from, let's say, here to here to here, though. I'm starting here, right? And I'm ending right here in this path. What is my distance if I walk that around like that, Krish? 8 meters, because distance, straight up total, right? What is my displacement if I go from here to here to here? Karis? 4 meters to the right, or some significant direction that was defined in the first place. But anything that makes sense if nothing is defined, okay? So does that make sense to everybody? Displacement is from where we started to where we ended. Okay, let's say we go the whole way around. I go from here to here to here to here and back. I do a lap. What is my distance? Yes. What's that? 12 meters. Okay. What is my displacement? Good. What's that? 0, right? If I come back to where I started. Remember, I said displacement is always really a measure from where I started to where I ended in terms of displacement, right? So if I come back to where I started, I don't care if I walked around for 4 hours, made all kind of turns, 1 million of them, and came back to where I started. Your displacement is still what? 0, right? This simple idea is really important to understand how to calculate correctly speed and velocity through a basic little equation. But if you don't get this simple idea, simply thinking speed and velocity are the same thing is just as bad as thinking distance and displacement are the same thing. Right? They can be very similar. One more time. What if I just go from here to here? I start here, I go to here, just along that first arrow. What's my distance? Somebody else. Yeah, go ahead. 2 meters. What's my displacement if I go from there to there? Go ahead, Charlie, again. 2 meters. You're right. The magnitude's the same, but since I said displacement, we also got to say something like what? Up or north or something like that. Okay? So there's not much more to say about that. Just understanding which one's distance is a scalar, displacement's a vector, and keeping that in mind when calculating it. Any questions on that? Okay, so there's some time to get started here. That's a simple idea to start, okay? All this terminology and stuff will be important all year long, so you don't get confused with bigger topics. So I want you to, for homework, and you can start now, complete that thing in Squid before you get in here tomorrow. It's not being checked for right or wrong, okay? I'm checking this for completion, but turn it in through Classroom. I'm just going to glance and put in a few points for you, 3 points I think I put on the thing, just for completing it. Upload it. If you have any issues, let me know right away tomorrow at the beginning of class. Don't panic or anything. We'll get stuff taken care of. One more thing I was going to say, and I forget what it was. Oh, after we go over it tomorrow in class, how I'll usually to quickly go over these. I want to spend a whole class period to go over them so we can get to the next lesson. I will quickly put the answer key up here tomorrow. And we'll go through them pretty fast unless there's questions and you raise your hand and want something explained more, okay? So please do that. Stop me when going over anything. If you need to explain more, I'll slow down and focus. But if a lot of this one should be pretty easy, straightforward, almost like factual information for the most part. And after I go over it in class, just for future reference, I will post the key. That is the same one you're going to see up here tomorrow. I will post it on this assignment. I will attach it after the fact, after it's due, okay? So that way, if you ever miss correcting it in class or or it could get messy correcting it over your own Squid thing, you will have the key version of it available after we go over it in class. Any questions about anything you guys need to do? Even anytime I give you time to start working, please use it. And if you're stuck on something while you're in here, I'm here. Ask me. Did you open up your Chromebook and we'll see if we can get it done? Open that up, get into it, and I'll help you.